Imagine looking at all the geometries, Euclidean, hyperbolic, spherical, and realizing that they could all be unified by a single brilliant idea. He saw it. Felix Klein didn't just do mathematics, he redrew its map. This is the intellectual journey of one of the greatest mathematicians of all time. The Greatest Mathematicians of All Time, Episode 53, Felix Klein. Felix Christian Klein was born on April 25, 1849 in Dusseldorf, Prussia, present-day Germany, and died on June 22, 1925 in Göttingen, Germany.
Klein's father was the secretary to the head of government. There is a picturesque description of Felix's birth in his obituary in the Annals of the Royal Society. Outside, cannons thundered against the barricades erected by the Rhineland insurgents against their hated Prussian rulers. Inside, although everyone was prepared to flee, leaving was not considered. That night, a son of the stern Prussian secretary was born. That son was Felix Klein. The revolution against the Prussians, which resulted in the dramatic birth of Felix Klein, was completely crushed in the summer of 1849. Klein attended the gymnasium in Dusseldorf. After graduating, he entered the University of Bonn, where he studied mathematics and physics between 1865 and 1866. He began his career with the intention of becoming a physicist. While still studying at the University of Bonn, he was appointed laboratory assistant to Plücker in 1866. Plücker held the chair of mathematics and experimental physics in Bonn, but when Klein became his assistant, Plücker's interests were already firmly rooted in geometry. Klein received his doctorate, supervised by Plücker, from the University of Bonn in 1868 with a dissertation on the transformation of the general second-degree equation between line coordinates into a canonical form on line geometry and its applications to mechanics. In his dissertation, Klein classified second-degree line complexes using Weierstrass's theory of elementary divisors. However, in the year Klein received his doctorate, Plücker passed away, leaving his main work on the foundations of line geometry incomplete. Klein was the ideal person to complete the second part of Plücker's Neue Geometrie des Raumes, and this work led him to meet Clebsch. Clebsch had moved to Göttingen in 1868, and during 1869, Klein visited Berlin, Paris, and Göttingen. In July 1870, Klein was in Paris when Bismarck, the Prussian chancellor, published a provocative message aimed at irritating the French government. France declared war on Prussia on July 19th, and Klein felt he could no longer remain in Paris and returned. He then served briefly in the army as a medical assistant, before being appointed professor in Göttingen in early 1871.
Klein was appointed professor in Erlangen, Bavaria, southern Germany, in 1872. He received strong support from Clebsch, who considered him a potential future outstanding mathematician of his time, and thus Klein held a professorship from the remarkably young age of 23. However, Klein did not build a school in Erlangen, where there were only a few students. So he was pleased to receive a professorship at the Technische Hochschule in Munich in 1875. There, he and his colleague Brill taught advanced courses to a large number of excellent students, and Klein's great talent for teaching was fully demonstrated. Among the students Klein taught in Munich were Hurwitz, von Dyck, Rohn, Runge, Planck, Bianchi, and Ricci Corbastro. Also in 1875, Klein married Anne Hegel, granddaughter of the philosopher Georg Wilhelm Friedrich Hegel. Grace Chisholm Young recalls the sunny days when the tall, handsome young professor courted and won over the lovely granddaughter of the philosopher Hegel. After 5 years at the Technische Hochschule in Munich, Klein was appointed to a chair of geometry in Leipzig. There he had as colleagues several young and talented professors, including von Dyck, Rohn, Studi, and Engel. The years from 1880 to 1886 that Klein spent in Leipzig would fundamentally change his life in many respects. As D. E. Rowe writes, Leipzig seemed to be an excellent outpost for building the kind of school he now had in mind, one that would draw heavily on the abundant riches offered by Riemann's geometric approach to the theory of functions. But unforeseen events and his always fragile health conspired against this plan. In him were two souls, one yearning for the quiet life of a scholar, the other for the active life of a scientific editor, professor, and organizer. It was during the autumn of 1882 that the first of these two worlds collapsed upon him. His health completely deteriorated, and throughout the years 1883 and 1884, he was tormented by depression. With his career as a research mathematician virtually over, Klein accepted a professorship at the University of Göttingen in 1886. He taught in Göttingen until his retirement in 1913, but from then on sought to re-establish Göttingen as the leading center of mathematical research in the world. His own role as head of a geometry school in Leipzig was never transferred to Göttingen. In Göttingen, he taught a wide variety of courses, mainly on the interface between mathematics and physics, such as mechanics and potential theory.
Klein established a research center in Göttingen that would serve as a model for the best mathematical research centers worldwide. He introduced weekly discussion meetings and a mathematics reading room with a mathematics library. Klein brought Hilbert from Königsberg to join his research team in Göttingen in 1895. The fame of the journal Mathematische Annalen rests on Klein's mathematical and administrative skills. The journal was originally founded by Klebsch, but only under Klein's management did it first rival and then surpass Prell's journal in importance. In a way, these journals represented the rival teams of the Berlin School of Mathematics, which ran Prell's journal, and Klebsch's followers, who supported the Mathematische Annalen. Klein formed a small team of editors who met regularly and made decisions democratically. The journal specialized in complex analysis, algebraic geometry, and invariant theory. It also provided an important space for real analysis and the new area of group theory. Klein retired due to health problems in 1913. However, he continued to teach mathematics at his home during the years of the First World War. It is somewhat difficult to grasp the importance of Klein's contributions to geometry. This is not because they are strange to us today, quite the contrary. They have become so much a part of our current mathematical thinking that it is difficult for us to perceive the novelty of his results, and also the fact that they were not universally accepted by all his contemporaries.
Klein's first important mathematical discoveries were made in 1870 in collaboration with Lie. They discovered the fundamental properties of asymptotic lines on the Kummer surface. A later collaboration with Lie followed, in which they worked on investigating W curves, invariant curves under a group of projective transformations.
In fact, Lie played an important role in Klein's development, introducing him to the concept of a group, which played a fundamental role in his later work. It is fair to add that Camille Jordan also contributed to Klein's learning about groups. During his stay in Göttingen in 1871, Klein made important discoveries about geometry. He published 2 papers on so-called non-Euclidean geometry, in which he demonstrated that it was possible to consider Euclidean geometry and non-Euclidean geometry as special cases of a projective surface with a specific adjacent conic section. This had the remarkable corollary that non-Euclidean geometry was consistent if and only if Euclidean geometry was consistent. The fact that non-Euclidean geometry was still a controversial topic at the time disappeared. Its status was equated with that of Euclidean geometry. Cayley never accepted Klein's ideas, considering his arguments circular. Klein's synthesis of geometry as the study of the properties of a space that are invariant under a given group of transformations, known as the Erlangen Program, 1872, profoundly influenced the development of mathematics. This work was written for the occasion of Klein's inaugural lecture when he was appointed professor in Erlangen in 1872, although it was not in fact the lecture he delivered on that occasion. The Erlangen Program presented a unified approach to geometry, which is now the accepted standard view.
Transformations play a fundamental role in modern mathematics, and Klein showed how the essential properties of a given geometry could be represented by the group of transformations that preserve those properties. In this way, the Erlangen Program defined geometry to include both Euclidean and non-Euclidean geometry. However, Klein himself considered his work on function theory to be his greatest contribution to mathematics. As W. Burrow and B. Schoenberg write, Klein considered his work in function theory the pinnacle of his trajectory in mathematics. He attributed some of his greatest successes to the development of Riemann's ideas and the close alliance he forged between the latter and the conception of invariant theory, number theory and algebra, group theory and multidimensional geometry, and the theory of differential equations, especially in his own fields, elliptic modular functions and automorphic functions. When considering the action of the modular group on the complex plane, Klein showed that the fundamental region shifts to tessellate the plane. In 1879, he analyzed the action of PSL (2,7) considered as an image of the modular group and obtained an explicit representation of a Riemann surface. As a curve in projective space, and its symmetry group was PSL (2,7) of order 168. He wrote The Theory of Algebraic Functions and Their Riemann Integrals. In 1882, he published a work dealing with the theory of geometrically shaped functions, connecting the theory of potentials and conformal mappings. He also used physical ideas in this work, especially those of fluid dynamics. Klein considered equations of degree higher than 4 and was particularly interested in using transcendental methods to solve the general fifth-degree equation. After relying on methods due to Hermite and Kronecker, producing results similar to those of Brioche, he completely solved the problem using the icosahedron group. This work led him to consider elliptic modular functions, which he studied in a series of papers.
He developed a theory of automorphic functions, connecting algebraic and geometric results in his important 1884 book on the icosahedron. However, Poincaré began publishing an outline of his theory of automorphic functions in 1881, and this led to a competition between the two. Klein began a correspondence with Poincaré, and a friendly rivalry soon arose, as both sought to formulate and prove a grand uniformization theorem that would serve as the pinnacle of this theory. Working under great pressure, Klein managed to formulate such a theorem and outline a strategy for proving it.
However, it was during this work that Klein's health deteriorated, as mentioned above. With Robert Frick, who arrived in Leipzig in 1884, Klein wrote an important 4-volume classic on automorphic and elliptic modular functions, produced over the next 20 years. We should also mention the Klein Bottle, a one-sided closed surface named after Klein. A Klein bottle cannot be constructed in Euclidean space. It is best visualized as a cylinder that curves back on itself to join at its other end. However, this is not a continuous surface in three-dimensional space, as the surface cannot traverse itself without a discontinuity. It is possible to construct a Klein bottle in non-Euclidean spaces. In the 1890s, Klein became interested in mathematical physics, although throughout his career he demonstrated that he never strayed far from this area in terms of attitude. Following this interest, he wrote an important work on the gyroscope with A. Sommerfeld. Later in his career, Klein became interested in teaching at the school level. W. Burrow and B. Schoenberg write, "From 1900 onwards, he began to show a keen interest in teaching mathematics at levels below the university level, without ceasing to perform his academic duties. A proponent of modernizing mathematics education in Germany, in 1905 he played a decisive role in the formulation of the Marana teaching plan. The essential change recommended was the introduction in secondary schools of the rudiments of differential and integral calculus and the concept of function. Klein was elected president of the International Commission on Mathematics Education at the International Mathematics Congress in Rome in 1908. Under his guidance, the German branch of the commission published many volumes on mathematics education at all levels in Germany." Another project he worked on around the turn of the century was the Encyclopedia of Mathematical Sciences. He actively participated in this project, editing with K. Mueller the 4-volume section on mechanics. Grace Chisholm Young writes about Klein's efforts on behalf of women in mathematics. When in 1893 he and others succeeded in opening the doors of the University of Göttingen to women, it was, I believe, a real pleasure for him that the first woman to receive the DPH degree did so under his auspices, and that she was a girl from Göttingen who had studied with his revered friend Cayley. Klein was elected a Fellow of the Royal Society in 1885 and received the Society's Copley Medal in 1912. The London Mathematical Society awarded him the De Morgan Medal in 1893. Chisholm Young writes, "His mind teemed with brilliant ideas and reflections, but it is true that his work lacked the rigor required by mathematical accuracy. It was in personal contact that this was corrected, at least as far as his students were concerned. His favorite maxim was, 'Never be boring.'" Throughout his life, Klein suffered several health breakdowns, including a severe nervous breakdown and depression around 1882-1884, and health problems so serious in 1911-1912 that he needed to spend a year in a sanatorium. These episodes led him to officially retire in 1913 for health reasons, although he remained intellectually active in Göttingen until a few years before his death, reinforcing the idea that his death was the natural outcome of health weakened by age. Obituaries from the time, such as the one published by the Royal Society, simply state that he died without pain in 1925, without mentioning a specific illness, something common for natural deaths of elderly academics during that period. Felix Klein spent his life fighting for a live-in, creative, and profoundly human mathematics. His Erlangen Program remains one of the cornerstones of modern science, and his vision transformed everything from geometry to school education. Today, every class, every calculation, and every new theory carries echoes of Klein's thinking. His legacy remains as infinite as the topology he helped to build.